This is a test review for Math 96 for Chapter 3 on power equations. Consider the data and the graph for the flow rate of water through a 1-inch pipe for different lengths of pipe. So here's the data in this table. These are the different lengths in feet, goes from 20 to 160. And these are the associated flow rates in gallons per minute, going from 96 down to 26. So I'm considering this my x and this my y, and this is the graph that depicts all of that data, these data points. Here's the length. Notice there's a typo on here. There's the length, and here are the flow rates, and this is for a 1-inch sprinkler pipe. All right, now on A it says find the slope between the 20 and 40 foot pipes and explain its meaning in context in a complete sentence. So I'm interested in 20 and 40. So these are the two x's that I'm interested in, and the y values associated with it. So it's 20 and 96 and 40 and 64. So slope is the difference between the x's divided by the difference between, slope is the difference between the y's divided by the difference between the x's. And that's what I'm showing you right down here. And it doesn't matter which one goes first. So I have 96 minus 64, which is on the top, and 20 minus 40, which is on the bottom. The thing that you have to be careful of is that the 20 and the 96 go together, and the 40 and the 64 go together. And so my sentence is, and I get an answer of negative 1.6, and I believe it stops right there. So my answer in a complete sentence is, between the 20-foot and 40-foot length pipes, the flow is decreasing 1.6 gallons per minute. Now I want to point out something to you. If you're going to use the word decreasing, do not put a negative sign in front of the 1.6, and that is preferred. And this is in context. It makes reference to both of the pipe lengths. It makes reference to the rate. On B, it says estimate the flow for a 30-foot pipe from the graph. And it's important that you notice that it's from the graph and answer in a complete sentence. So I'm looking for 30 feet. Well, 30 feet is right in here. Estimate the flow for a 30-foot pipe. So I'm right in here, and I come right up the middle, and I come across, and my estimate was somewhere in the neighborhood of 76. So you need to be able to read these increments over here. It's broken down into 5, so it's increments of 4 gallons for each little jump. So that's my estimate. For a 30-foot pipe, the flow is estimated to be 76 gallons per minute. You have to make sure that you do not go back and try and grab data out of the tables or use any kind of an equation. On C, it says estimate the length of a pipe with a flow of 40 gallons per minute from the graph and answer in a sentence. So I find 40 gallons per minute, which is right here, and I come straight across and I find that on the graph. My estimate is 80. It looks, in looking at it again, it's probably just a smidge more, maybe 81, but 80 is nonetheless a good estimate. So I say with a flow of 40 gallons per minute, the estimated length of pipe is 80 feet. D, use regression to find a power equation to model the data. Round the numbers in your equation to 2 decimal places. And so that's what I did. I entered this data in my calculator. I selected the power equation under which kinds of regression I wanted, and these are the values that I got. So the equation is y equals 652.04 times x to the negative 0.63. On E, use your equation to estimate the flow for a 30-foot pipe. Now notice up here on B, I was using the graph. Down here, they want me to use the equation and then compare the answers. So that's what I did. So here's my 652 times 30. I put 30 in for x to the negative 0.63, and I ended up with 76.50. So when I compared the two, 76.50 using the equation and 76 just reading the graph. So they were very, very close to each other. So it was a good estimate. On F, use your equation to estimate the length of pipe with a 40 gallon per minute flow rate. And again, up on top on C, I had to look at the plot. Down here, I'm going to be using my equation. So I put 40 in for the y equals 652.04 times x to the negative 0.63. Divide both sides by the 652.04, and then use that little operation for my exponent 1 over 0.63, and that's a negative. And I get an answer of 83.97. When I compare that to what I had up here on C, I had 80 up here, almost 84 here. They're close, not as good as the other one, but still very respectable. Use your equation to predict the flow for a 200-foot pipe. Again, put 200 in for x, solve, I get 23.154, and my answer is the predicted flow for a 200-foot pipe is 23.154 gallons per minute. Make your sentences as precise as you can. Make sure you use the numbers and the units appropriately. And finally, on H, use your equation to predict the length of a pipe with a flow of 12 gallons per minute. So I put the 12 in for my y. I'm looking for x. The first thing I'm going to do is divide both sides by the 652.04, which I'm showing you right here. And then to get rid of that exponent, I'm going to be raising both sides to the power of negative 1 over that exponent, negative 1 over 0.630. That leaves me with x by itself. I put all of this in my calculator, and I end up with 567.70, and that's feet. So my answer is the predicted length of pipe for a flow of 12 gallons per minute is 567.70 feet. And that's the end of this test review, although I will mention to you that the test on Chapter 3 will also be including the use of a quadratic equation.